In this video, I hope to show that the following equations are what are called power functions. A power function is any function that can be written in the form y equals kx to the n, where k and n are real numbers. So for the first equation, y equals the cube root of x squared, this does not look like a power function because of the radical symbol here. However, what you should have learned in a previous class, or perhaps this one, is that there's a rule of exponents that says if you have something of this form, the nth root of x to the m, that it can be rewritten as x to a fraction. So for example, in my case, m is 2 and n is 3. So I should be able to write this as x to the 2 divided by 3. So that would look like this. And once I did that, once I wrote this as x to the 2 divided by 3, notice that my k would be 1, and draw a little better 1 there, and my n would be the 2/3. In my next example, it's almost exactly the same, except the power isn't written, and the index is not written. However, since the power isn't written, it's assumed to be a 1, and since the index isn't written, it's assumed to be a 2. So it turns out the square root of x can be written as the second root of x to the first, in which case you could simply write this as x to the 1 divided by 2 using this property right here. This would be x raised to, again, the power gets divided by the index, so m divided by n would be 1 divided by 2. So it turns out the square root of x can be written as x to the 1/2, and again, this is a power function because my k, my coefficient, would be 1, and my n would be a half. Remember, n only has to be a real number. It can be a fraction, decimal, it can be positive or negative, whatever you want, as long as it's a real number. Y equals 1 over x, again, does not look like a power function. In fact, you have x in the denominator. But again, this fact that it's a power function relies on a exponent rule that you should have learned in intermediate algebra that says that you can bring x to the numerator, since it's a factor. You can bring it up and just change the sign on its exponent. So since the, not the sign, yeah, the sign on the exponent. Since the exponent is a 1, you can move x to the numerator, since it's a factor, by just changing the sign on the exponent, meaning the sign was a positive, and now I wrote it as a negative. So again, this is a power function because k would be 1 and n would be -1. So here's another example of something that does not look like it could be written in the form kx to the n, but on further investigation, it can be. So a similar example would be if you had 5 over x cubed. Again, since x cubed is a factor, you can bring it to the numerator, change its sign from 3 to -3. That would look like this. So 5 stays in the numerator. The x cubed being a factor can be brought up into the numerator, and I change the sign from 3 to -3. And again, this would be a power function because k is 5 and n is -3. Now, if you're doing the Math AS question that looks like this, which one of the following is not a power function? Let me see if I can clear the board up a little bit. Perhaps I just slide this over. The question looks like this. It looks a little nasty. Which of the following is not a power function? So I clearly already did this one, and this one in the video. What I did not cover is y equals x squared plus 1. This is not a power function because in the general format here for a power function, there is nothing in there that allows for addition or subtraction. So if this equation would have just been y equals x squared, this would have been a power function because k would be 1 and n would be 2, but there's no allowance for addition or subtraction in a power function, so that makes this the correct answer. I know you didn't see the question, but the question is to mark which one is not a power function, so that would be this one.